name is Stefan Hoppe. I'm the President and Executive Director of the OPC-Foundation. And this time I have a little bit a different approach to explain what OPC UA is and where we come from and what we do. And think about this, OPC UA is a basic technology, and there are two other talks right after me building on top of OPC UA. So let's talk about connectivity, and you see here the pavilion future of connectivity area, and how do we connect machines to services, how do we connect machines with each other horizontally. And this is exactly what the OPC-Foundation as the organization is delivering with the technology called OPC UA. And we do it in a way that we want to change the way of communication. On the left side, you see the old automation pyramid, where each layer has their own dedicated protocols. And the old thinking, the old school of thinking, is exactly thinking in protocols. I want to exchange data with somebody else. Okay, what kind of protocols are you supporting? What are I am supporting? Oh, something is matching. Then we first select the protocol, and then we think, how can we put the data into the transport? That's exactly the old school on the left side. And in the middle, you see a more meshed, a mesh network, where it's completely different, where I say I'm describing the data and services I have, and in my pocket, I have couple of transport mechanisms built in, including security, and it's an offer to you, and you can select whatever information you want. And one of the protocols, they are hand-selected because they are state-of-the-art, and they are fulfilling exactly what you need. So I'm more talking about an information network and service network where you can select what do you need. And this is exactly the approach of how OPC UA works. Nice music here. Hard to concentrate. And this is exactly how OPC UA works. And inside OPC UA, there are a couple of protocols. If we look now on a super high level, what is the OPC-Foundation delivering? What are partners together with the OPC-Foundation delivering? OPC UA is the framework. It has a modeling language to exactly describe my capabilities, my offerings, my services. There are a couple of protocols in the body, TCP, UDP, MQTT, REST interface, and it has integrated security. That's a technology, and OPC-Foundation itself is the largest ecosystem for industrial interoperability. It has super modern IPR policies as a patent protection umbrella. All standards are worldwide free available, free of charge. We are even harmonizing standards that we don't end in different interfaces for energy or OEE data or whatever. We have open source offerings and education offerings for academic programs and so on. And together with partners, and that's why we are here, for example, with VDMA or VDW, we define domain-specific companion specifications. It describes a domain-specific semantic. That's exactly the next two talks where you should listen to. And together these groups are also doing educations and hackathons to ramp up the implementations. Again, in easy language, if you think about Lego bricks, then every Lego brick has a dedicated job to do. For discovery of machines in the field, for security, for whatever. And then you have a long, big list of Lego bricks, but these are hard to order, right? How do you order a machine, a CNC machine, and then you have a long list to describe the Lego bricks you need? That's inefficient, and that's why you also can buy with Lego these pre-packages, and then Lego guarantees that everything is inside the package. You can't fail. And this is exactly what we call companion specifications. And a companion specification is exactly describing a machine. For example, I am a CNC machine plus the behavior of the machine. That's what we call companion spec. And sometimes I also get the question, okay, there are so many Lego bricks, then OPC UA is super complicated. Do I have to implement all Lego bricks? And my message is no, because the feature set is scalable. It is same like the Swiss knife, where you have one edition on the left side offering all the tools, but if you say, oh, that's too heavy for me, I don't need that because I'm walking, I like walking, whatever, and I don't do camping, so then you take a lighter one, right, which has less features implemented. And this is exactly the reality where you say, okay, maybe my CNC machine should not talk directly to the cloud, so please delete the MQTT feature or the REST feature, because a CNC machine is not providing directly to the IT world a REST interface. Yes, that makes sense. May make sense. And in addition, if you have just a gateway collecting data from the south port from machines, and you offer transport that, deliver that to the IT world vertical, then in this gateway you might not implement TSN and Ethernet APL. Makes sense. So please scale it as you like. Talking a little bit deeper now in this modeling, what is OPC UA, what is security? I have one slide each for what is OPC UA. I'm not going through to anything here. Again, it's a completely independent standard. It is not belonging somebody. It's not one specific big vendor behind. It is not bound to any market. It is completely open. It is it's supported by multiple programming languages, multi-vendor. OPC UA is international. It's an IEC specification, but it's also a local standard in China, in Korea, Singapore. So that's where we are really proud on. We have over 900, that's an old number here. We have over 950 members, meanwhile, worldwide. And it is about 80% are all the big OT companies. Every big automation company you might know. Siemens, Rockwell, Schneider, ABB, Phoenix, Beckhoff, B&R, Vago, and all these ones. But also a lot of the big IT companies. If you believe OPC UA is just for the OT world, please open your mind. IBM, Google, Microsoft, AWS, hopefully I have not forget, IBM are all members of the OPC-Foundation. So it's really the community where the IT and OT world comes together. And remember what I mentioned before, they made a patent protection agreement. Having Google, AWS, Microsoft, SAP, and all the big automation vendors protecting this technology, you can feel really sure and safe, secure. OPC UA scales. It is not only exchanging data between two machines, between a robot and injection molding machine. It is also from the OT world, from the machine up to IT levels. Not only inside the edge to MES, SCADA, MES, ERP. It is also scaling up to digital clouds, digital twins, the metaverse, between digital twins, and from the cloud back to the devices also. This is what we cover. As mentioned, it has a super rich modeling language. It does not mean that everything you model needs to be complicated. It just says the capabilities are so rich that you can describe everything, even a chair, a lamp, or whatever, which has no connectivity. But you can model everything. You can describe everything. Also the behavior. Security is baked in. I have one extra slide on that. But that's critical important because we are no longer just securing the data transport, also who is able to see and access and read and write what kind of information. Transport, as mentioned before, it is just baked in. Transport is not number one, where you first select the protocol and then exchange data. It's exactly the opposite. First you model your data, and then we have protocols like TCP and UDP and MQTT and AMQP and REST. And whatever comes in the future and has relevance for the market, we can integrate this. So you can keep your information, but we take care that industry relevant transport mechanisms are integrated. For example, 5G, Ethernet APL, it's ready, yeah, we are ready. We don't have to change anything. But we are not responsible to find use cases for 5G. This is what the 5G people have to think about, right? Mobile robots is mentioned always. Okay, good, understood. But if you need it in additional scenarios, it's their topic. Robustness and reliability. If we would exchange cyclic information about, hey, I have new data and so on, and somebody's unplugging the cable, this does not mean that, and somebody's re-establishing the connection, is re-plugging the cable a little bit later, this does not mean that the information meanwhile will get lost. In short, for technology people, each message has a unique number. There's a dead heartbeat. If something gets broken, both partners know I'm disconnected, they can start buffering. If you reconnect, somebody says, I lost 40 frames, please resend. Everything baked in. And it's extendable. Okay, one slide for security. Security is not only built, so it's on 3 pillars, what you see here from left to right, enabling technology, that's a technology, it's baked in by design. Then we have a continuous monitoring process, and we have education and guidance. OPC UA security is baked into the spec from begin, and nothing just later on. If you have, for example, Modbus, it has been designed so early, at that time nobody took care on security. Today you have to make a secure pipe to then tunnel unsecure Modbus through this secure tunnel. It's completely different with OPC UA. OPC UA brings security out of the box. You don't need additional other security. You need to configure and enable the security with certificates, yes. But security for transport layer, encryption, signature of each message, and so on is baked in from begin. And also who is able to see and access and read and write what kind of information. So it's also on application and user level. And we also addressed the topics of how to exchange all the certificates, certificate management. A person is leaving a company, he was a maintenance person. So all wind turbines in the world where he had access might be in a potentially bad situation if you are not in a good relationship with your employee, right? So you want to roll out new certificates. All this can be handled with a technology called GDS, also based on OPC UA, to roll out new securities and delete others. The continuous monitoring means that weekly we have meetings of our 25 best security experts, and they are acting on the one hand reactive. Something happened in the world, somebody said, oh, I was able to break in OPC UA, and then they are analyzing. Mostly, until now, it was never OPC UA itself, it was underlying infrastructure. And then they can make recommendations. Oh, in the .NET tool, if you build your server with .NET, please deactivate this flag because it can influence your server, whatever. And they are proactive, recommending new security mechanisms to be integrated into the OPC UA standard. ECC is one of these, I tried to spell the name, it's ecliptic curve cryptography. And the translators will have the same problem like me, right? We are even sponsoring hackathons where professional hackers try to break into OPC devices. So we are spending membership money to donate it to professional hackers. Please try to break in our system. We are doing this since multiple years. There's a huge event in United States, in Florida always, and we are one of the sponsors. And we do guidance and education. As you see here, nobody is able to read the whatever number of specification pages on security. We shrink down everything to at least, at the end, 1 page. It's here, this brochure. It's 1 page which everybody should follow and say, okay, this is my process to make my machine secure. And we have been proud that we have been reviewed by the BSI Germany twice. Meanwhile, also the France government, with their security, is looking on OPC UA because of the relevance, and even the Homeland Security, the FBI in North America, is looking on OPC UA because of OPC UA in critical infrastructure in North America. And obviously, the O from OPC-Foundation stands for openness. Everything what is found or what they document is public. That's the only way to survive in the future. To give somebody a black box and say, hey, trust me, it's with this box you're secure, it doesn't work. Okay, next slide. I talked a little bit about that it's the world's largest ecosystem. And I think I mentioned all these names here. But I didn't mention all the end users: Samsung, Volkswagen, L'Oreal. Procter & Gamble, meanwhile, joined the OPC Foundation. By the way, one of their criteria to select, I think we can name that, to go in future with Siemens, congrats to Siemens, was that Siemens has much better integrated OPC UA compared to other large automation vendors in other continents on the world. Miele, Foxconn, so really big names, as mentioned before. Think about the Swiss knife. So we have modeling capabilities, we have security baked in, and we have multiple transport layers. Now what to do with that? I'm just explaining the base for the presentations coming later on. Write companion specifications, which means domain experts should come together and model, I'm a CNC machine, I'm a robot, I'm an injection molding machine, I'm an RFID reader, I'm an electrical coffee machine. Everything of that is existing. You shouldn't start with that. So overall, it's 121 plus information models. And that's exactly where round about the half of them are driven by VDMA. And Mr. Andreas Fahrt will do a presentation after my topic talking about the focus of the VDMA. Half of them roundabout are from VDMA, but the other half are from totally different areas in the world where VDMA is not really focused on. Process industry and other topics. What I like to announce that you get a broader picture is that OPC Foundation is heavily extending now information models for the energy world, driven by large companies like Equinor, the Norway oil and gas company, and by others on carbon capturing. So that's really so. How can we exchange information from wind turbines, from solar panels? All these green energy stuff which is coming up should have standardized information models from begin, right? And just to give you one example, OPC UA is also growing into the labs, the devices which you put on your table and which are analyzing the behavior of the COVID virus. Is your probe infected or not? All these vendors came together and everybody is implementing OPC UA, and they do it very highly efficient. They are coming even with competitive companies together, organize hackathons, and within 2-3 days you have your server up and running, and competing companies help each other, sitting together on different tables. Here's a table where everybody who is implementing in .NET should sit, and here's another table for everybody who's implementing in Java. And then they help each other. Oh, how did you load the information model into the open source or into the toolkit from company XYZ? And loading the information model is half a day or 1 day to understand this. You can even compile your code, you can browse in and see everything. And the second day is, okay, how can I connect to my physical machine? What is my last mile, my proprietary last mile to get the information into the OPC server, right? And then after 2-3 days, you have your server up and running. Okay. So if you have this huge number of information models, then obviously you need a lot of harmonization between the groups. This is where we perfectly partner with VDMA, because they do harmonization in their 50 groups, and we do harmonization also, and we combine everything together that everything fits perfectly together. So we have a really good collaboration here together with the VDMA and others being connected here. With my last, so obviously I can talk for the rest of the day here and share interesting information on how OPC UA grows down to the field level. OPC UA, meanwhile, is also available for controller-to-controller company. If you have a plant and you have two machines, one is with the Siemens ecosystem, another one with Rockwell, with Beckhoff, Phoenix, Vago, how are they able to connect horizontally to each other? And sometimes you even need horizontal safety, functional safety. And this is also what OPC UA is delivering. There is an OPC UA safety spec. Right now, the stacks are getting ready, implemented, but the spec is available and companies are implementing it. And we also made a huge demonstrator how all these companies internationally exchange data via UDP in a super fast way. I'm now talking a little bit more on OPC UA to the cloud, the last few minutes, where I believe maybe this is not on your scope. Because everybody has in its mind, OPC UA is the last mile to the machine, which I can touch always. And I like to open your mind here. OPC UA is scaling to cloud systems for applications. And it is because inside OPC UA we have these multiple protocols. Not only TCP, not only UDP, which is more for field level and factory, inside factories, it also has MQTT baked in. But MQTT on its own is not enough. Everybody is promising, yeah, I have MQTT, but this means nothing. At the beginning, Siemens, Beckhoff, Vago, Phoenix, all of them had integrated MQTT into their controllers. But everybody made it on its own flavor. And if you would have told them, please share one variable called temperature1 with a value 42, you would have received on the receiver side always MQTT, but with 4 different encodings, where the information inside the MQTT is always different. It's like Modbus. Oh, if 4 people can talk Modbus, it doesn't mean they can automatically understand the information, because you don't know how the information are available inside Modbus. And that's same with MQTT. So what we did is, in February 2018, we published a specification OPC UA over MQTT. So standardized information, how do we transport them over MQTT? And this resulted in that major cloud companies, AWS, Google, IBM, Microsoft Azure, Siemens, MindSphere, SAP, all agreed we will implement OPC UA over MQTT, because then we have a super large pool of information sending us information, and we do not need any specific routine to get the data out of MQTT. The first company who delivered was Microsoft Azure. The second company who delivered is the AWS, and Siemens MindSphere also delivered, and SAP announced to have it end this year, early next year. Really cool, makes me really proud. This and by the way, and the OT companies also implemented this. So Siemens, Beckhoff, Vago, Phoenix now also in addition implemented OPC UA over MQTT. You can tell them post the same message, post the same value, temperature1, and it's arriving semantic identical at the cloud vendors, and you don't need any adaption routine. Really cool. And important to understand is this message doesn't need to come out of a full-blown OPC UA server. It can also come out of a 8-bit chip with 2 kilobyte SRAM. Super small hardware-constrained devices. It is just how do I send MQTT messages out to the world. This is the benefit of really this kind of OPC-Foundation, where I believe it's not only doing standardization, it's also connecting people, right? It's like a movement worldwide. Hey, let's come together, let's share smart brains and make the world better. I have to skip dramatically a lot of slides, just 2 of them. We are also connected to digital twins, data spaces, the metaverse. For example, here I selected one case study where you have a production chain and all of the companies who deliver parts to build, for example, a robot are uploading their carbon footprint of that piece. And all these information are in a data space. So you don't need an asset administration shell for that. You can just collect data here directly into a data space. OPC has restarted the REST interface group. So again, it is available, but we want to extend it, make it better. Immediately, companies like Shell and others joined because they are so much on renewable energies and they want to have super easy access. REST is easy access. You don't need to study big specs. You just have the REST interface, what you put in your URL, and then you get from the standardized information, you get exactly the information, what you want, what you are interested on. It's not for deterministic data exchange. It's not for super fast millisecond. It is, I want to know what's happening right now. Huh? The metaverse, we made a demonstrator how to connect it to the metaverse. Even that 3D and everything is virtual. At a specific point, you want to connect to the real world, and then you need OPC UA. I'm skipping a few slides here, which are just that OPC UA has been selected in the process industry in different areas, oil and gas platforms. There is open source, there is a starter kit, there are success stories, and this is where I talk just 1 minute. There are different success stories from pushing data from oil and gas to Microsoft Azure, in production, discrete manufacturing, from Renault to Google. What I highly ask you to read is the success story from company Miele, because Miele first decided to create all new production lines with OPC UA, and then they figured out the big value on having standardized information, higher security, that they decided even to save money by renew their existing production lines. What you know, normally nobody is touching a running machine, right? I've been a software engineer, never touch a running machine, never touch a running process line, a production line. In maintenance phase, they did it and they renewed everything, and you should read the story why. It's just 4 pages, easy written. Their success stories, they convinced all of their suppliers and they wrote it down. 100% of our suppliers, we ask for, please, friendly, please deliver OPC-enabled devices, otherwise you are out of business. And they did. And that made their life much more easy, right? Okay. There's a brochure. Some of them are here available, just a few, but you can also download it from the OPC web and from the OPC booth over there. And that was my presentation. A little bit different than normally, but hopefully you enjoyed. Thank you so much for attention.